The average American household runs 300 gall of water through its pipes every single day, and every drop of it arrives through infrastructure that's bleeding water the whole way. In America, around 20% of treated fresh water is lost to leaking pipes before it ever reaches a tap. And in much of Europe, that number climbs past 30%. Water is one of the most overlooked resources we have, and most homeowners take it for granted. We've got solar figured out and wind on the radar, but water is the gap nobody talks about, right up until a shortage hits or the aquifers run dry. But 6 systems I'm about to share can change that. There are some of the most innovative ways your home can collect, pull, and store its own water right now. And every one of them is a real product you can buy or a proven build you can put in yourself. Some, like number 4 on our list, can use the energy generated from your solar panels to pull a fully off-grid water supply straight from the air. While number 1 strips out up to 99% of the parasites in your water using nothing but sand and a living colony of organisms that nature grows for free with no power. No chemicals and no filter to ever replace. All right, let's get into it. Number 7, fog harvesting. First up at number 7, we have the Cloudfisher Fog Harvester. Picture a ridge on the coast of northern Chile in the Atacama, a desert so dry that some weather stations there have never recorded a drop of rain. And yet, most mornings, a thick bank of fog rolls in off the Pacific and soaks everything it touches. That's the exact situation fog harvesting is built for. You're somewhere it doesn't rain, but the air around you is loaded with water. The method for getting it out is almost too simple. Fog is just a cloud sitting on the ground made of water droplets between 1 and 40 micrometers across, so light they drift sideways on the wind instead of falling. Stretch a fine mesh across their path and the air slips through. But the droplets are too heavy to swerve with it, so they smack into the fibers, merge into bigger drops, and run down into a gutter and a tank below. No power, no pump, just wind and gravity. The best mesh in the world for this is the Cloudfisher, a 3-dimensional spacer fabric from the German firm Aquilonus that catches roughly a third more water than the old flat netting and shrugs off winds up to 75 kilometers an hour. In Morocco's Anti-Atlas Mountains, a field of them pulls thousands of gallons a day out of fog in a place with almost no rain. The catch is that Aquilonus only sells at the community and commercial scale, so there's no boxed Cloudfisher you can stand up in the backyard. So for a single home, this one's a build rather than a purchase solution. You buy the fog-catching mesh and make the frame yourself. A food-grade 35% rational mesh sold specifically for fog capture, like the polyethylene fog catcher mesh from Hortimalis, runs a few dollars a square yard. While it's about 30% less effective at capturing moisture than the Cloudfisher, this is currently the only option for a residential project. Once you've got this, stretch it across a frame of PVC or copper pipe with a sloped trough underneath. You can build one for around $130 or perhaps even less if you scavenge the frame. But before you spend a cent, be straight with yourself about your site, because there's one limit no clever mesh can fix. Fog harvesting only works where fog is frequent, dense, and driven by wind, coastal ridges, high desert plateaus, and hillsides in an ocean fog belt. Put a net up in the Midwest or the dry interior, and it'll sit there bone dry. So, map your fog honestly first, ideally with a small test collector over a season. And where the fog is real, you've got a water supply that costs almost nothing to run and never send you a bill. Number 6, Blue Barrel Rainwater Catchment System. So fog only pays off in a few special places, but this next one works on almost any house that has a roof, and most of us are pouring its harvest down the drain. Every inch of rain that falls on a 1,000 FT roof drops about 600 of clean, soft water. And on the average house, every gallon of it runs straight down the gutter and into the storm drain. But catching rainwater is the oldest and most obvious water harvesting method ever devised. What's changed is that the system's got modular and cheap enough to be worth it. The standout for a normal home is the Blue Barrel Rainwater Catchment System, a kit built around recycled food-grade barrels. You run a diverter off your existing downspout into a row of barrels, and the clever part is that Blue Barrel plumbs them from the bottom rather than the top, linked underneath. The whole row fills and drains as one big tank from a single inlet. Sediment settles low and stays out of your water, and you can bolt on more barrels whenever you want without touching the rest. And the economics are about as friendly as water storage gets. A kit runs roughly $25 to $78 per barrel, plus about $36 for each recycled drum. So a serious multi-reel setup lands in the low hundreds of dollars while storing hundreds of gallons. And in a lot of the country, you can wipe out most of that cost with a rebate because San Diego pays $1 per gallon of storage you install, and the SoCal Water Smart program pays $75 a barrel, enough that a decent system can come close to free. If these aren't available in your area, then the easiest way to begin storing rainwater from your roof is via one of Home Depot's 50-gallon systems. They're more expensive and aren't modular, but they're a good start for collecting rainwater for outside use. Number 5, the source hydro panel. But what happens when there is no fog, no rain, and no accessible aquifer? An environment like this is the sort of place the source hydro panel was designed for, and the exact reason why it has been deployed in the Dubai Desert, in Saudi Arabia's Enion project, and on native reservations in the American Southwest, where grid water infrastructure simply does not reach. Source was founded by Arizona State materials scientist Cody F. Zen, who raised over $270 million from backers like Jeff Bezos and Bill Gates with the goal of bringing drinking water panels on roofs. In the same way solar took over electricity, the source hydro panel pulls it off with no electricity at all. Sunlight drives air through a hygroscopic material, a substance that grabs water vapor straight out of the air the way a dry sponge pulls in moisture. And then solar heat raises the temperature inside until that captured vapor condenses into liquid. From there, the water is mineralized for taste and sterilized, stored in a sealed reservoir, and dispensed from a tap, all powered by nothing but the sun. Source has put these panels in more than 50 countries, often in remote communities miles from any pipe. And it's an ingenious system, but it comes with some real drawbacks. The biggest being its output. A single panel makes only about a gallon a day, roughly 180 standard bottles a month. So it's strictly drinking and cooking water, and a household needs a small array of them. But even more problematic, the company has been facing serious internal issues as well as questions over its quality. While the rollout of their product looked promising for a number of years, now they've shifted to a, quote, only community and commercial deals with no public pricing for homeowners. And even when they were publicly available, they were expensive, with a single panel array costing in the region of $6,000 to $12,000 after installation. While the hydro panel was certainly an exciting evolution in the development of off-grid water supply, it's looking increasingly likely that we'll have to wait a bit longer before we get a truly effective solution. Number 4, Aquaria Hydro Pack. While a hydrop panel might not be feasible right now, the Aquaria Hydro Pack certainly is. Aquaria is currently manufacturing some of the finest atmospheric water generators in the domestic market right now. These AWGs run like air conditioners in reverse, with a powered compressor chilling a coil, drawing moisture out of the air the way it does on a cold glass. And then it's filtered, mineralized, and UV sterilized to beat EPA and WH standards. What makes these truly impressive is that they have the potential to be an entirely off-grid water supply. A single hydro pack makes up to 132 gall a day, plumbs into your house, and runs from an app, and can be fully powered from your PV solar array. Aquaria also sells various smaller and larger versions, from the countertop Hydropixel at about 24 gall a day, up to the dual Hydropack X with an output of 264 gall. But of course, none of this comes cheap. The Hydropack runs about 20 taus, $499 before installation. Financeable around $27 a month, and at roughly 0.93 quat-hours per gallon, it costs about 13 cents a gallon in power, far more than the half-cent you pay for city water. So it isn't here to beat the cost of the municipal tap. It's here to beat the realistic off-grid alternatives, which are drilling an $80,000 well or trucking in water at $2 to $5 a gallon. And against those, making your own out of the air starts to make a lot more sense. There's also another important caveat here, and that's the climate. These machines are rated for warm, humid conditions and need relative humidity above about 30% to work well. So output collapses in very dry or freezing air. Number 3, the gravity-fed spring box. The spring box requires no solar panels, no pump, no filter, no treatment system, no electricity, and no ongoing cost of any kind. It delivers pressurized water directly to your home's plumbing at 43 psi for every 100 vertical feet between the spring and your tap, mimicking municipal water pressure. Exactly. But this is the geological lottery of off-grid water systems. If you have the right land and conditions, then you're sitting on the winning ticket. Nothing else on this list competes. A spring forms where percolating groundwater hits an impermeable rock or clay layer and is forced sideways until it emerges on a hillside. The water has already been filtered by potentially hundreds of feet of soil and rock. The job of the spring box is not to filter that water, but to capture it cleanly, protect it from surface contamination, and deliver it under gravity pressure. And the output is hard to argue with. A trickle of just over 1 gall a minute adds up to more than 2,000 gall every single day, which is enough for a large household and a serious garden at once. The whole build, concrete and pipe and gravel, comes in under $1,000. And because there's nothing mechanical in it, there's nothing to break. The USDA's Natural Resources Conservation Service even publishes the full development standard for free, the same one farmers and conservation districts use. But of course, the catch is the one you can't engineer around, which is that you need a spring sitting at enough elevation above your house. So, a site assessment before you ever buy the property is worth more than the spring box itself. And the rule that protects what you've built is to keep livestock and surface runoff well uphill of the collection point with a fence and a diversion berm, because the spring's purity comes from the ground, and the only way to ruin it is to let the surface back in. Number 2, solar direct submersible well pump. If you don't have a spring but you're sitting over a decent aquifer, the well is the obvious answer. And for a long time, pulling from it off-grid was a miserable proposition. A conventional well pump runs on AC power and demands a big battery bank, an inverter, and a startup surge that punishes every part of the chain. So most homesteaders gave up and ran either the grid or a generator out to the wellhead. What changed it is the solar direct brushless DC pump. And the heart of it is a controller running maximum power point tracking. That's a small processor that watches your solar panels constantly, and as clouds and sun angles shift through the day, adjusts the pump's speed in real time to draw every available watt. The pump runs straight off the panels with no battery in between, slowing when the sun dims and speeding up when it clears. 2 names own this space. Grundfos makes the SQL line. 11 models, spanning from deep high head wells reaching past 800 AUD-FT down to shallow high volume ones. And they'll run on solar, a generator, or batteries without modification. Laurent makes the PS2 family from the PS2 600 for a remote home up to the PS2 400 for serious irrigation, both with brushless stainless motors and dry run protection that cuts the pump the instant the well runs low. Laurent rates its systems above 90% daily efficiency, even under overcast skies. The trick that makes the whole thing work is that water is your battery. The pump fills an elevated tank through the day, and that tank gravity feeds the house through the night. So, you store water instead of expensive lithium with nothing to degrade over time. The pump hardware itself runs $2,000 to $4,000. And for anyone with an existing well and a dying AC pump, that swap pays for itself in the first season of not running a generator. But the real cost, and the one number that decides the project, is the well itself. Because drilling a new one runs anywhere from $15,000 in easy ground to $80,000 in hard rock. So size the system to your total dynamic head. The full vertical lift, plus the friction in the pipe before you buy a thing, because a pump matched to the wrong head either can't lift your water or cost you double for power you'll never use. Number 1, integrated rainwater catchment with bio and filtration. Every system so far depends on something your land has to give you. Fog, a spring, an aquifer, or humid air. Number 1 needs none of them. It works almost anywhere rain falls, costs less than any of them to run, and turns that water into safe drinking water with no electricity, no chemicals, and nothing you ever have to buy again. And the way it does the cleaning is the most counterintuitive idea on this whole list. Almost every modern treatment method works by destroying pathogens, whether that's reverse osmosis, UV, or chlorine, all of which need power, replacement parts, or both. But a bio-and filter does the opposite. It cleans water by growing a living thing inside a column of sand and letting that ecosystem do the killing. In the top inch or two of always submerged sand, a slimy biological layer builds up with a German name that translates as dirty skin, the Schmutzdeck. It's a dense, hungry community of algae, bacteria, and protozoa. And as water trickles slowly down through it, those organisms eat, outcompete, and hunt the disease, causing microbes passing through. The water comes out clean, not because the sand sterilized it, but because nothing harmful survived the crowd. The numbers of this system are real and independently checked. The CDC and WHO have both documented bio-and filters, removing up to 99.98% of protozoa and around 99% of bacteria, including E. coli, plus a real cut in viruses on nothing but gravity. And this is not fringe because London ran its drinking water through slow sand filtration, the city-scale version of the same trick for most of the 1800s, long before chlorine existed. But the household design was perfected in the 1990s by Dr. David Manns at the University of Calgary, who patented it in 1993 and then gave it away through a nonprofit called Caused. Their concrete version 10 filter cleans up to 9.5 gall an hour, costs under $100 in materials, and is documented to still work after 30 years. If you'd rather not pour concrete, the plastic hydrate does the same job in a lighter vessel. More than 1.7 million of these are now in use across 60 plus countries. And because there's no cartridge and no subscription, nobody makes recurring money off them, which is a fair part of why you've never seen one advertised. Bolt that filter onto the rainwater you stored back at number 5, fed through a first flush diverter off a metal roof, and you've got a closed loop from cloud to tap. The one rule that keeps it safe is to leave the living layer alone. When the flow finally slows, You gently scrape off just the top half inch and let the colony regrow over a few days, running a second filter or a reserve in the meantime. Starve it, scrub it, or let it dry out, and you kill the very thing doing the work. None of these 5 systems is a single answer. The right architecture depends entirely on what your land offers and what you need to guarantee. If your property has elevation and a spring seep, develop the spring box first. It costs the least, produces the most, and requires no power of any kind. If you have a well, then a solar direct pump with elevated storage and a biowind filter on the drinking water circuit is one of the most resilient combinations available. Or, if you are in a high rainfall climate without groundwater access, integrated catchment with bio-infiltration is your foundation. The principle that connects all 5. Separate your water by use. Drinking and cooking need roughly 1 gallon per person per day. Total household demand, according to the EPA, averages over 300 gall. The critical supply is small. A source hydro panel can guarantee it even when every other system is under pressure. Build your volume supply separately from whichever spring, well, or rainfall system your site supports. And if you are on a coastal ridge or high elevation site that sees reliable fog, do not overlook number 5. A system with 0 operating cost, 0 consumables, and a modest footprint that produces hundreds of gallons a day does not need to be your primary supply to be worth building. The municipal water system was never designed with your resilience in mind. These 5 where the knowledge of how to build them is available. The materials are accessible and the physics is on your side. There is one question none of these 5 systems answers on its own. Where does the power come from to run the parts of the system that need it? That is the next piece of the architecture, and we have already built it out for you. If you want to see how these water systems pair with the energy infrastructure that keeps them running, then take a look at our breakdown of the 5 home energy storage technologies built for exactly that job.